we will determine the common ratio, which will be 4/8 is also equal to 2/4. And when you do that, we will get our common ratio is 1/2. So in this case, our common ratio will be equivalent to 1/2. When we get our common ratio is equivalent to 1/2, we are going to take the formula here. This is the formula we are going to use when R is less than 1, you can see. And we say that when R is less than 1, when R is less than 1, we use the formula A minus 1 minus R to power n over 1 minus R. That is the formula that we are going to be using. So we are going to take, in this case, the sum of n will be equal to A into brackets 1 minus R to power n over 1 minus R. And the sum of 7 is equals to A is 8 into brackets 1 minus R. Our R is 1/2, so it will be 1/2 to power 7 over 1 minus 1/2. That is it. So the sum of the first 7 terms will be 8 into brackets 1 minus 1/2 to power 7. 1/2 to power 7. 1/2 to power 7 will be equal to 1 over 128. 1 over 128. Then divide by 1 minus 1/2 is 1/2. So the sum of the first 7 terms will be equal to 1 minus 1 over 128. It will be 127 over 128. Then we divide with 1/2. We divide with 1/2. We get 1 whole 63 over 64. Then we multiply by 8. And we are going to get the sum of the first 7 terms will be 15 whole 7 over 8. 15 whole 7 over 8. So that is how we determine the sum of geometric sequences and series whose radius, not radius, whose common ratio is less than 1. Is less than 1. So I think we can have some questions here to do, and they be of help to us. So let us continue. So let us proceed with the next question. So this question reads, the first term, the first, the third, and the seventh term of an increasing arithmetic progression are 3 consecutive terms of a geometric progression. So this is a combination of the two. The two of them have been combined in one concept. The first, the third, and the 7th term of an increasing arithmetic progression are 3 consecutive terms of a geometric progression. If the first term of the arithmetic progression is 10, find the common difference of the arithmetic progression. So we are being told we have an AP and a GP. So we have the first term, the third, and the 7th of a arithmetic progression. So we have the AP here. They form the first 3 consecutive terms of a GP. So let us interact with such, because such are the ones that are assessed in the national examination. So tunaambiwa the first term in an arithmetic progression we know is A. The third term in an AP is A plus 2D. I hope you know where it is coming from now. And the seventh term is A plus 6D of an increasing arithmetic progression are 3 consecutive terms. They are 3 consecutive terms. Consecutive means the first 3 terms of GP zikifuatana. So ya kwanza ni A, ya pili ni AR, na ya tatu ni AR squared. I hope you now know where these 3 are coming from. This is the first term of a GP, the second term, and the third term. We form the first 3 terms, the first consecutive terms of a GP. Then tunaambiwa if the first term of an arithmetic progression is 10. If the A is 10, A ya AP ni 10. A ni 10. So we can now replace this with 10 plus 2D, na ingine ni 10 plus 6D. Hizo ni za AP, ndizo zinapelekana na za GP. Hii ya AP ya kwanza ni hii ya GP ya kwanza. Hii ya pili 10 plus 2D ni AR, na ingine ni AR squared. So zinakaa hivyo. So swali letu linasema if the first term of the arithmetic progression 10 is 10, find the common difference of the arithmetic progression. So kama hii ni ya kwanza na hii ni ya pili na hii ni ya tatu, ujue hizi hazijafuatana. Hii haijafuatana na hii. Hii ni ya kwanza, hii ni ya tatu, hii ni ya saba. But hizi zote tatu zina form hii ya kwanza, yani hii ni equal na hii, na hii ni equal na hiyo, na hii ni equal na hiyo. Kumaanisha ukichukua hii divide by E, AR udivide by A utapata radius common. Common ratio. Na ukichukua AR squared udivide na AR bado utapata common ratio. In both instances tutapata common ratio. Lakini hizi values za hizi bado ndizo hizi. Kwa hivyo ni kumaanisha for us to get the common difference as the question reads, we can say that 10 plus 2D over 10 divided by 10 should be equal to 10 plus 6D over 10 plus 2D. That is what it means. Juu hii ina form hii na hii ina form hii. So tukitake hii to divide hii inafaa iwe equal to, zote mbili zinafaa zitupatie common ratio. So hii ni common ratio na hii ni common ratio. All R, this is the same as saying R is equals to R. So tuseme 10 plus 2D over 10 is equals to 10 plus 6D over 10 plus 2D. So in that situation what we do, we now cross multiply. Huwa tuna cross multiply. Tuki cross multiply tutachukua 10 plus 2D to multiply na hii ingine 10 plus 2D should be equal to 10 into brackets 10 plus 6D. Na tukifanya hivyo itakuwa we open the bracket here 10 into brackets 10 plus 2D plus 2D 10 plus 2D should be equal to 10 times 10 is 100 plus 10 times 6 is 60D. So tukifanya hivyo to open hii bracket 10 times 10 ni 100 plus 20D plus 20D plus 4D squared is equivalent to 100 plus 60D. Tukipata hivyo, so hapa ni kuweka like terms pamoja. Hii itakuwa nini? 100 plus 20D plus 20D itakuwa 40D plus 4D squared is equivalent to 100 plus 60D. So tutazileta side moja zote, this will form a quadratic equation ambayo itaanza 4D squared. So tukileta hii na huku itakuwa plus 40D minus 60D. Tena tukileta 100 na huku itakuwa plus 100 minus, ikikuja na huku itakuwa minus, so hiyo minus 100 is equivalent to 0. So hii itakuwa 4D squared 40 minus 60 itakuwa nini? Minus 20d, then 100 minus 100 ishe iwe equals to 0. So tumebaki na 4d squared minus 20d is equivalent to 0. So ikifika hapo tutadivide na 4 na 4 na 4. Tukidivide na 4 tutapata d squared minus 5 is equals to 0. Hii ni 5d, sorry, 5d is equals to 0. So this is a quadratic equation, we can factorize. So the common factor here is d. Tutoe d nje tubaki na d minus 5 is equivalent to 0. So d is equal to 0 or d minus 5 is equals to 0. So our d will be equal to 0 or our d will be equal to 5. In this case we will ignore 0 because hatuwezi pata common difference ikiwa 0. So our d will be equal to 5. Our d will be equal to 5. So that is how we do that question. Let us proceed and do another example.